day since we have we know?
I don't know. Ladies, do we have a joke of the day since we're starting a recording? I know it's a lot of pressure without advance warning. You think you got one? You want some time to think? We don't have to do it right now. We can throw it in anywhere.
Jewish fact
Wait.
of the day.
I'm
Be
trying to
quiet,
think.
Leo.
I have one. It's more of like, okay. Parallel lines have so much in common. It's a shame they'll never meet.
Oh.
I tried really hard not to laugh. That's so dumb. Okay, now you're going to be punished for that joke. What's an inscribed angle?
An angle on the circle.
What's on the circle?
The vertex of the angle.
So any angle with its vertex on the circle is an inscribed angle.
Yeah.
Yes?
Yeah.
Okay, let me click to the next slide and debate that point with you.
Okay.
The left picture is not much different than the other one that we just had on the previous slide. That is in fact an inscribed angle. Is this an inscribed angle?
Yeah.
Okay, that's an easy answer. What about this guy?
Yeah.
Yeah. So as long as the vertex is on the circle, that's an inscribed angle.
Yeah.
No.
Okay.
So I will tell you this one and this one are not inscribed angles. So can you clean up your definition a little bit to include the left one but exclude the middle and the right one?
It's an angle on the circle, but the two arrows have to be in the circle.
But the one on the left doesn't have any arrows.
The line segments.
The line segments of the angle?
Yeah.
The line segments of the angle have another name.
Sides.
What about the sides of the angle?
Are within the circle.
Nicely done. As I said when we started the chapter, the question that we're going to continue to ask ourselves as things get more complicated is, where is the vertex? So now we're going to get to two scenarios. The one we've already done, which is the central angle. And what's the relationship between the central angle and the arc? They're congruent, correct. Now we have the second scenario, which is when the vertex is on the circle itself. And as Natalie clarified, the sides of the angle have to be inside the circle. So the middle one and the right one are not inscribed angles, only the left one. We good so far?
Yeah.
Okay, good. I've used this term before, but I never thought to define it until I was doing the slideshow. This term intercepted arc means the arc that's intercepted by the angle itself. So we had intercepted arcs when we were dealing with central angles. I just never thought to define it, but now we have it. Okay, so that red is the intercepted arc of angle A, B, C. What's the relationship between the intercepted arc and the non-intercepted arc? George?
I got up to 360.
They add up to 360 because that'll give you the entire circle. Okay, so that's just a terminology point so that we can use the same phrases when we talk about different parts of the circle. Here's the big relationship though. The inscribed angle is equal to half the measure of the intercepted arc. Central angle and arc, 1 to 1. Inscribed angle and intercepted arc, 1 to 2. Okay, so took a circle, put an inscribed angle in it, and measured the inscribed angle. The inscribed angle is 21.57 degrees. The intercepted arc, which is the orange one, is 43.15. In case you can't do the math in your head, that turns out to be 1/2. Watch what happens when I move B. Well, you tell me, what happens when I move B?
The one on the far right bottom is not going to change at all.
The one on the far right bottom.
The
This won't change?
Yeah, that was.
What about these guys?
Yeah, they'll change.
Okay,
So
good.
this is
But that's wrong.
Never mind.
What just happened?
Nothing.
Oh, no, a lot happened.
Well, the vertex moved, but
Correct.
none of the measures changed.
Why?
Because it's still the same angle.
Why?
Because we didn't make it bigger or smaller, all we did was move the vertex.
What if I move C?
Then the angle will get bigger,
And what happens to the arc then?
it gets bigger.
Good. So notice, no matter where I put B, it stays the same. This is what the program is doing. It's actually recalculating these two things over and over and over again, but it doesn't change, so it doesn't appear to you that anything's changing. But just to show you, if I move C, then things change. Now, big question, what happens if I bring B all the way around here and put it on the orange? What's going to happen? Nathan?
I think it will cease to exist.
I will cease to exist?
disappear.
Inscribed
It's the
angle.
weirdest thing during class. The teacher is playing with this program and moved a dot, he just disappeared. Maybe they'll put like a plaque up in the corner of the room for, what's today, the 6th, right, 6th?
Yeah.
Yeah.
In loving memory of Mr. Reading.
Thank you. Who ceased to exist because he moved a dot. It's a hell of a way to
Died
go.
moving a dot.
So I'll disappear, what will disappear?
The inscribed angle. I don't know.
All right? Anybody else? Go ahead.
Would like if you put B in between A and C, would AC become the arc? Like the whole other
Top
part?
colors.
If you put B in the orange, would the green become orange?
Okay, so question number 1, how big, here, let's make this easier to do some calculations here. Oh, can't get that close to, that's close enough. If the green arc is 50, then you're saying that the green arc, if the orange arc is 50, then the green arc would be,
Wait, what?
if the orange arc is 50 degrees, how
Oh.
big's the green arc?
310.
310. And if I move B over to here, what's that gonna be? No pun intended.
What? Oh,
Get it?
yeah. Would it be 50, 310? I don't know.
No.
No? Okay.
Move the wrong one. I'm a doofus. I'm just afraid of disappearing, that's all. There we go.
Never mind.
Well, you're on the right track. But now explain to me where that 154 came from.
Does it overlap? Or no?
No?
No, I don't know.
Listen.
Isn't it still from the ABC, because technically there's still a vertex that's on the circle
Mhm.
and 2 chords. So that's just that angle, the ABC.
Yeah, so you're on the right track. We changed the intercepted arc. When B is over here, the intercepted arc is the orange one, so this is half of that 50 degrees. When we bring B over here, the intercepted arc changed, and now we switch to the green arc, which we haven't measured, but if I did, it would be 300 something, 310. And that becomes half of the intercepted arc, so now the intercepted arc is green. This is also why that gets screwed up, because that's no longer dividing the right angles. I would have to take the green divided by the angle. Okay, so the intercepted arc can change depending on where the point is. For the most part, however, we're going to look at scenarios like this. No matter where I drag B around the green arc, it's going to stay the same measurement, and that arc is going to be twice as big. Okay? Back to the slideshow.
Go back.
Oh, yeah. There you go. Do you have something you want to say before? You got it. And so if ABC is 105, then that's going to be 210. Double the angle to get the arc, cut the arc in half to get the angle.
Wait, so would it be arc on top and angle on the bottom as a denominator? Or
Doesn't matter, you can set it up either way, you can do 2 to 1 or 1 to 2.
Okay.
Just remember the angle is smaller than the arc. Now we're good?
Yeah.
Okay. How big is angle MPQ, Erica?
1 second.
All right.
Uh, 56.
No.
Oh,
Good.
7.
You
Just
put
cheat.
the,
Oh, okay.
you put the 109 at one time.
Yeah. You want to take a look at throw that and that's where we. Sorry, Erica, what do you got?
70.
Nope. So this is going to seem like a simplistic approach, but we need to start breaking it down this way. So here's the thought process. Where's the vertex? Correct. Where is P? On the circle. So if it's on the circle, what's the relationship between the angle and the arc?
Is it half?
Good. So how big is angle P?
35.
Bingo. It seems silly because we've only talked about the central angle and on the circle, but we're going to get like 6 different scenarios of where that vertex can be. So eventually it's going to get more complicated. With that same idea in mind, how big is arc PN, Raj?
112.
112. Right. Double the angle to get the arc. Okay. Any issues there? Beautiful. How about this guy? Arc ST is 68 degrees. Find the measure of angles 1 and 2. Stell, what do you got for me?
Yeah, hold on.
Okay, I'm gonna. You ready?
I'm not sure.
Okay. So let's do angle 1 first. Where's the vertex?
It's R, so it's, oh wait, what's the vertex of what?
Angle 1 we're talking about.
Oh, it's R.
And where is R located? You only got 2 answers to that question right now. Is it on the circle or at the center?
On this.
On the circle. What's the intercepted arc of angle 1?
ST.
Good. And so if the angle is on the circle and it intercepts the arc ST, what's the relationship between the angle and the arc?
Oh, the angle is half the R.
Beautiful. So how big is angle 1?
34.
Well done. Now, with that same idea in mind, how big is angle 2?
34.
Why?
Because it's like the same thing as 1, so basically since 2 is like the intercepting arc of angle 2 is ST, then it would be 34 since it's half.
Wunderbar. Well done. What if I put in angle 3? How big is angle 3?
34.
And angle 4?
34.
Well, that's a pitiful angle. Whoops, no, angle 4. And we get the idea, right? Does it matter where I put the vertex? As long as it's not on ST, we're good to go. Which leads us to this theorem. This theorem. If two angles intercept the same arc, they're going to have the same measurement. So you saw that all of those angles, 1, 2, 3, and 4, were all the same measurement because they all intercepted arc S. Was it ST?
ST.
ST, thank you. Good. We're not going to do this one because it's the exact same problem we just did. What's the relationship between angles R and O? Yeah. They're congruent because they intercept the same arc FG. So what would you do with the two algebraic expressions? Set them equal, solve for x, and then what do you do with x? Substitute it back into angle O. You get an answer of 47. Not real exciting. Let's talk about something more exciting. How big is angle B? No. Let's hear from, you want to take a shot at it?
Yeah, is there not enough information?
Oh, there's plenty of information. Still want to take a shot at it?
Um,
Or are you going to wuss out?
Is it like what the exact measurement of the
Yep.
angle is, or just what can you say
No,
about it?
well, either one. We can talk like,
Well,
kind
you
of
can-
like Zen feelings, first and then get into the nitty gritty of a numerical answer, or?
Well, you can figure them out based off of the arcs.
Keep going.
I just feel like there's not enough information to find out the.
There is, I wouldn't lie to you.
Alright, yeah, toward,
Wow. Are your shoulders tired
what?
from carrying that attitude around?
Yeah.
Did you get that on the recording?
Yeah, it's recording. It's on there. We can listen to it over and over again. Put your hands down. She's got this. Go.
Okay, so, I mean, I know how you could figure it out, but I don't know because there's not any measurement. Oh, if that's
Oh, the light
180
bulb just went on.
if AC would be 180 degrees, right? 'Cause
Well, okay, I know what you mean, but let's fix the vocabulary.
Okay.
Angle AMC is 180 degrees, right?
yes, and
Right.
so the arc
Because
is
segments can't really be
right.
degrees. Okay.
So angle ABC is also 180 degrees, or arc ABC.
Arc ABC is in fact 180
180
degrees,
degrees.
also known as
A semi
semi-trailer,
Semi-arc?
semi. What's the prefix semi mean?
half
Half. It's half of a
circle,
semicircle. Good.
Okay, and
I like where this is going.
wait, am I finding angle ABC?
Yes, angle B. ABC.
Angle B,
It's easy as
okay.
1, 2, 3. Do re mi.
So if you know that the arc ABC is 180 degrees, then I'm trying to figure it out.
I understand.
How
big is the other arc?
Which
By the other arc, I mean
AC?
this guy. I should have put a point here, so let's call this D as in donkey. How big is arc ADC?
180.
Okay,
So
does that help?
I just don't know if I'm looking at it right.
Try like this. Does that
Um,
help at all?
no,
What if you go like this?
that doesn't help either.
How big if you turn it over completely?
No,
No? What if you close one eye and then open the other eye real
No.
quick, so it like flashes back and forth?
no,
No, that's not helping?
no.
Okay.
Uh,
Where's the vertex?
B
And where is
Wait.
that located?
on the circle.
Okay. And if the angle is on the circle. Somebody else just got it.
Gosh, I know once I hear the answer I'll feel silly, but
What, like clown silly or?
no, like stupid silly.
Oh, I understand.
Let's
review.
Okay.
You've told me that B is on the circle.
Yeah.
You've told me that arc ADC is 180 degrees.
Yes.
So what you haven't told me yet is what's the relationship between the angle and the arc when the vertex is on the circle? Which is what we've been doing in this whole slideshow.
Yeah, I don't.
We do that thing in Jeopardy or whatever game show it is where you like help.
Can I phone a friend?
Oh, phone a friend, that's
Cash cow.
Who wants to be a millionaire?
Oh,
Okay.
cash cow.
Can you phone a friend in cash cab?
Yes,
Yeah.
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 So you're gonna phone a friend?
Yeah.
Alright, is Caitlin your
Do you
friend?
want me to phone Find my phone.
You're the phone, so you have to shout, "Hey, she needs your help!"
Do you want to be the friend?
So
Okay.
A and C is 180 and B is half of that.
Oh. Okay, so it's 90 degrees.
Good.
Okay.
What if I move B?
Because of the inscribed, I do feel silly.
I
Because
understand.
of the inscribed angle.
What if I move B over here?
It would still be 90 degrees.
What if I move it over here?
90 degrees.
What if I put it here?
90 degrees.
Here?
90 degrees.
So hopefully we can generalize that to say what?
That, as another theorem,
Oh, sorry. No. What can you tell me about any
Yeah,
angle
any-
inscribed in a semicircle?
okay, any angle that you move from the vertex is the same.
Mm-mm. What can you tell me about any angle inscribed in a semicircle?
Oh, it's 90 degrees.
Bingo. Good. Okay. Did you have your hand in the air? Like you just don't care?
Yeah.
Okay, good. This thing is called, did you have a question or are you just waving your hands around?
I was just waving my.
Doing some aerobics or some yoga back there,
Yeah.
right? Half moon pose.
It was child's pose.
Oh, what was
Not
it?
with your hands in
Wait,
here.
isn't that one of them?
But you're like
No.
laying down.
Yeah, that's
Oh,
laying
that's,
out.
that's the only one I
He
know.
was doing cactus.
He was doing what?
A cactus.
Oh yeah, okay, good. This is called a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral with all four vertices on a circle. It doesn't have to be a special quadrilateral. It could be. It could be a square. It could be a rectangle. But this is just any quadrilateral. When you have a cyclic quadrilateral, the opposite angles are supplementary. That's not true in every quadrilateral. Just to review, it's been a while since we've done quadrilateral. It's true in a square and a rectangle, and a rhombus, and a couple others, but it's not true in any particular quadrilateral except this cyclic one. So the question is, why is angle A plus angle B equal to 180 degrees? This one's a little challenging.
Can you repeat that?
Why is angle A plus angle C equal to a $1.80? Are you raising your hand or just,
Wait, no, I thought I had something, but that doesn't make sense.
and then it left you?
No, it just doesn't make sense.
I understand.
Question.
Question?
Yeah, does it have to do with semicircles or?
Nope. Leo?
So
Is not a good way to start an answer.
since A is on the circle, then the arc of DB is like, let's say X.
Which DB?
DCB.
The major arc DCB?
Major arc DCB, yeah. Let's just call that X for now.
Why can't we call it arc DCB?
We can get it, sure.
Okay.
DCB. And then arc, well, since angle, point C is on the circle, and arc DAB makes up the remainder of the circle. So that's like the whole circle, so that's 360 degrees. And then if you take the, since the angles are half of the arc, it's going to be 180 in total. So that's why it's supplementary.
Everybody follow that?
No.
Yeah.
No?
No.
No,
No?
I'm confused.
Okay. Angle C intercepts the arc DAB, which is blue.
Oh.
Sorry. Get another epiphany. Angle A intercepts the arc DCB, which is red. So we don't know how big angle A is, but we do know that it's half of the red. So angle A is equal to half of the red. And we know that angle C is equal to half of the blue. We're looking for angle A plus angle C. Well, that's going to be equal to half of the red plus half of the blue. What's red plus blue?
You were walking into that one.
I totally asked for that one.
Yeah, you gotta draw faith +1 for that one.
No, it was Caitlin. It was Caitlin.
Whoever said that.
Caitlin.
Was that you?
Share it.
Kate.
What was it?
That was, it was you?
Yeah.
Yeah, it was
Okay.
Silly art jokes.
Now I'm totally off track. 1/2 times red plus blue. Do not say purple again. Okay, factor it out of 1/2. What's the measure of the red arc? I wised up here. Plus the measure of the blue arc, as Leo already said,
360.
360. So therefore the sum of these angles have to be equal to 180. The same is true if you look at angles D and B. If we get rid of all this mess, angle D intercepts the arc from A all the way around to C, and the angle B intercepts the arc from A all the way around to C. Those green, the green and the black one together make the entire circle. That's why we get that. It's gotta be cyclic though. People have a tendency to see 3 points on a circle and then they just automatically assume it's cyclic. All 4 have to be on the circle in order for this to apply. It's not a very common theorem, but it will pop up occasionally.
That wouldn't work with parallelogram. Never mind. Scratch it.
Never mind, keep
Never
going.
mind, never mind.
Keep
Well, what do you
going.
know about a parallelogram? What do you know about the opposite angles in a parallelogram?
Never mind. That's what I said. The opposite angles are, oh no, wait a second. Right.
Hold on, he's working through an issue
Yeah,
here.
the opposite angles are congruent,
Correct?
so it would not work.
Unless the parallelogram
Is a square.
or rectangle, correct. Question?
Yeah, so if you have a circle and you have like a quadrilateral and then there's 3 points on the circle and 1 point like out.
Off doing its own
Yeah.
its own thing, yeah?
Would the,
No,
never mind, I got it.
it doesn't work. The theorem is invalidated. Okay, let's we're running out of time here. We got to talk about some pi here. So let's do this one quickly together. What's the relationship between angles 1 and 2? Hanks? You started this mess. What's the relationship between angles 1 and 2?
They equal 100. No,
Nope. Let's back up. How big is angle T?
90 degrees.
Good. How big are, what's the relationship?
90 degrees. They're the same. No, they're not the same. Well, they're. Yeah.
Are those new boots you have on today? Those are really nice.
Oh, thanks. No, they're not new.
No?
No, they're not. Thanks for noticing that.
Uh-huh.
Um,
Those new glasses, they're really nice.
No.
They look good.
they're not new.
No. So what's the relationship between those two angles?
Well, I know that 4 and 2 are congruent.
Are you wearing your hair differently? Looks really nice today.
Ah, I see what he's doing.
Anybody?
Oh, yeah, I get it.
Complementary.
There you go. They're complementary angles.
Really
180
good.
degrees, 90 out of there. That was kind of creepy, wasn't it?
It was.
Yeah.
They're just. Yeah.
They're equal to 90 degrees. So what do I do with these two equations?
Set them equal to 90.
Set them both equal? No.
And I'm like, you know what?
I know what you mean, but you're not saying it right.
You.
Wow, now we got an attitude. Now you're angry. I can see it. You're just like.
I'm rattled. You add them and set them equal to 90.
Thank you. What's the relationship between angles 4 and 3? No.
They're congruent
Tell me why.
because angle QSP intercepts arc PQ and angle RPS intercepts RS, and those are congruent.
Well done. What do I do with the two algebraic expressions then?
Set them equal.
Set them equal, solve for y. Okay. Question?
Technically, I'm just so complementary though. Are they both just 45? Because isn't angle P that doesn't have a letter on it S? Isn't that 90?
No.
It's not on the.
Oh, it's not. Gotcha.
Okay.
I gotcha.
Alrighty. Let's stop there. Good job.